Okay, guys, so we're ready to start.
Oh.
So we're using Rob's computer and he's on call. So we might have to stop in the middle if there's any problems with Netflix. Hi, my name is KATRIEL. I work for the Waze infrastructure team. We're based in Tel Aviv. This presentation, I'm presenting it just because I could be here. The other two guys that work with me, Iran and Tom, also worked on this presentation, so credits due where credits due. About Waze, just a little bit, if you're not familiar with Waze, what we do is turn-by-turn navigation, which means taking you from point A to point B. We're mainly focused towards commuting, daily commuting, getting from work to home and home to work. Some stats, we have about 80 million monthly active users, which for us is people who drive more than 5 days a week. We have more than 100 microservices, 500 pipelines and growing. I think, I don't know how accurate that number is right now, probably even more when we speak. We use two cloud providers, both Amazon and GCP. I don't know if you're aware of it, but Waze was acquired by Google some 4 years ago, so kind of makes sense for us. Other big things that we do are the carpool project, if you're familiar with it, which helps to pair drivers and just people who want to get to work. So we match someone who's going from the same neighborhood to the same workplace or work area, something like that, which is something which has actually been opened here in the Bay Area. Another big thing we have is the CCP, the Connected Citizen Project, which is a project where we team up with municipalities, cities, departments, state of transportation, stuff like that. And we share speed information with them, accidents, and other reports, and they share with us road closures. The local police usually knows best when there's planned events and stuff like that. We also use it for stuff like that's going on now with the hurricanes. So we use that. The local municipality can give us information about shelters and where to find gas and stuff like that. We can relay that using Waze to our users. So that's what we do. So where we were 2 years ago and where we are today, this kind of sort of will help us frame the problem that we were having. 2 years ago, or maybe even 3 years ago, we were mainly using big-ish services. Okay, so single process that will handle a lot of kinds of requests, stuff like that. And in terms of deployment velocity or upgrade velocity or new feature velocity, it was kind of low because the infrastructure team, were always man in the middle. The development team never had or didn't have the right tools for pushing out updates to production. So we always had to, they would open a bug for us and we'll take care of it. Sometimes sometime in the future, if we're busy, then tomorrow in a week, whatever. So as you can see, we were kind of a man in the middle. We were slowing stuff down, but we could live with it. And what happened about a year ago, an entrepreneuring developer decided that he had to write a lot of new features. So we decided instead of adding them to new servers, he will just write them in new servers, new microservices. So what he did was he took our entire default stack, okay, data persistency, our IPC layer, configuration, everything, and put it all inside a single jar. Okay, a single jar that meant that all you had to do is use Gradle, add that jar as a dependency, and write your business logic, and you're done. Everything else, a few lines of configuration, everything else was taken care for you. So what happened in a matter of weeks, all of a sudden we had 20 or 30 microservices waiting for us, the infrastructure team, to be deployed. So when we ended up with all kinds of new microservices, made a few, for example, cars. engagement, and pickup, which is not what you might be thinking. So yeah, we were kind of a bottleneck, and this is just a recent example of how our system looks today. Okay, so the upper layer is services. Okay, all the services in our system. Each one could be thought of as a single server group. Okay, the middle layer is the services they provide. What we call them subjects. Okay, and the lower layer are clients. So you can see how such a big system can get very hard to manage over time and very complex. So the problem that we had we had hundreds of Spinnaker clusters. Like I said, we were responsible for doing all the upgrades. We usually did them in an ad hoc manner. So the developer would ask us to upgrade. We'll go to our upgrade utility. We'll set the new version. We'll do an ad hoc clone. We'll wait. We'll monitor. We'll see everything is okay, and then move on to the next upgrade. Obviously, when we started using Spinnaker, one of the first things we started to implement was pipelines, because that meant we can automate much of these things, what I just specified, the waiting, the cloning, everything. So pretty fast, we built our perfect pipeline, okay, the one that did exactly what we want and fit most of our applications. And that pipeline started to be copied over from application to application. Someone would deploy a new application, so he'd take that pipeline, do some copy pasting, renaming in the JSON, the pipeline JSON, and start working. So, but that poses a problem, right? There's no code reuse. Every change you want to make across all your pipelines is a lot of work. What ended up happening is that we didn't use pipeline as much as we wanted. We'd have a few here, a few there, and then we'd wait for it because we still wanted to perfect that one, because we still didn't want to copy it over because the application wasn't ready. So you can see it ended up with us not using pipelines as much as we'd like. So we had a few, but not as much as we'd liked. And automating the process was actually writing pipeline templates, right? It was something that we weren't prepared to take on ourselves. To have some external source of truth to configure the pipelines, that was something that we weren't able to do. So the solution just presented itself. Pipeline templates. So we've been asking for this feature for a while now. The Google Spinnaker team can attest, and actually in the UI there's a copy stage, a feature where you start a new pipeline, you can copy stages from other places. That's actually a future request that we made. Thank you, Daniel, if you're here. But that wasn't really enough, because we still had to manually assemble a pipeline. We still had to either manually assemble or copy, paste, rename, which was never a good way to work. Enter manage pipeline templates, which is exactly what we were looking for. What that gives us, what that gives us is a few things. First of all, pipelines are checked in code in Git. Okay, so there's an audit trail. There's a review process for any change you want to make in the infrastructure. It's easily shared between other team members. For developers, it's something that's relatively easy to grok, okay, to understand that it's a tool they know how to use already. And actually what it implements is infrastructure as a code, right? So I'll have a server group that has min-max 3 instances and 9 instances, and now I have, for some reason, I need to up the max to 12 instances. I have an audit, I have a review. I can ask a team member to check it out before I do any changes, and just deploy them, run the pipeline, and whatever changes I made are there. So kind of infrastructure as a code. And what it really gave us, which is what we were looking for, is a paved world for developers. So we, the IFS, the infrastructure team, can work on that golden pipeline and have it the way we want, and then give it to the developers to reuse. So most of our microservices, I'd say 90 to 95% are all the same, right? It's the same application, uses the same kind of images, uses the same kinds of load balancers, whatever. So just reusing it 99% of the time, it's fine. And for the 5% that remains, so we do some manual alterations or we write one-offs and we're good. So that's where we are. That's where we are today. Yeah. So what are pipeline templates? So pipeline templates are templated pipelines are actually composed of two main parts. The first one is the pipeline template, okay, which can define things like stages, variables, configurations, and stuff like that, and has an inheritance model where I can define currently only a one-off inheritance. I can't have a template inherit multiple templates. It has to be like the word single inheritance, right? So and so you can define different stages and just stack them all together, and you have a pipeline. So that's the template. Templates can be configured with reusable things like modules and partials, and there's a whole model of where you can inject and replace parts of objects with by specifying the JSON path, stuff like that. The templates themselves and the pipeline configuration use Jinja, if you're familiar. And the other part is the pipeline configuration, which is actually the part that mutates the template into a runnable pipeline. So I can have a single template, have 3 different configurations, right? Each one using the pipeline in a way that is a bit different parameters, okay, different regions, different providers, whatever. And the result is a runnable pipeline, which I can run and rerun as much as I like. By the way, feel free to stop me if you have any questions. There will be time at the end to ask some questions too. So what I wanted to do now is just go over a simple template, a very simple template, just 2 stages with a wait and a wait stage and a manual judgment. And then I have a little YouTube movie, which a colleague of mine made, which will show you some more advanced uses, which you can later see for yourself. So like I said, the template itself is composed of a few parts. The first one is metadata. So you can see the important part is the ID, which is the part which I reference in the configuration when I create my runnable pipeline. And there's some metadata like the name, the virtual and description, owner, stuff like that, some boilerplate stuff. And second part is configuration. So this is, as you can see, this is all translates to the UI, if you're familiar with the pipeline UI. So these are one-to-one parameters, triggers, and stuff like that. And then the important part is variables. So in the template, I can define variables, which are later on used inside stages to mutate the stage, to configure it. There's also conditional stages where I can run a stage only if a certain variable is set to true or something like that, which helps you where you can control the flow. For instance, if you want to destroy a group or disable a group, so you can have both stages in your template, and then use a variable to decide for this pipeline, this runnable pipeline, I want to destroy the group, and for that runnable pipeline, I want to disable the group. Okay, so I'm just highlighted here a variable named wait time. So in the next part is stages. So you can see we have 2 stages. The first one is called wait, and the wait time will later on be replaced with whatever you configured in that variable. And then there's the manual judgment, which depends on wait. Okay, that's how we define our dependency tree. And a few configuration for that specific stage. And you can see, again, this maps to whatever you see in the UI. So there's nothing surprising here, right? If you know the UI, templates will look pretty clear to you, I think. Then the pipeline configuration itself, which is what, like I said, mutates the template to create the runnable pipeline. So you can see the application which is the Spinnaker application it's going to appear in, the pipeline's name, the source, which is Spinnaker sample template. So there's three sources. There's file, which looks for files on disk wherever Orca is running, I think. There is HTTPS, so you can have template source from an HTTPS source. And there's Spinnaker, which actually means use templates from whatever front 50, wherever front 50 stores them. It can be S3, it can be GCS, whatever. And I've specifically configured that wait time to be 120 seconds. Okay, so when this pipeline is run, it will wait for 120 seconds and then show me the manual judgment stage. Okay, any questions? So I have okay. So to publish that pipeline currently, there's no other way but to use it's a tool called ROAR. I have no idea who named it, but ROAR is a simple Spinnaker API client. So the first thing I'll do is I'll publish the template, okay, and that talks with Spinnaker and through front 50 stores it in our case it's GCS, and then I'll publish the pipeline itself, which refers to the template. And there's some checks that are done during publishing and during runtime to make sure that everything is okay, although we would like some more. So I have a short video here which shows some more advanced features that a colleague of mine made. It sometimes runs a bit fast, but there's links on the end of the presentation which we will share. We will share with the presentation. There's a few links in there, and there you can watch the movie. So we added it. There was I don't know if we can go back. So we injected a stage, and you can see before disable clusters. So without really having to be familiar with the whole dependency tree, you can just inject it, and Spinnaker will take care of reordering all the stages. So this fits in whatever you specified. See that only the pipeline number 2 has manual judgment injected to it. Okay. So the template itself has a variable called destroy previous group, and it's by default set to false. And the destroy server group stage has a conditional when, that will, which means it will only run when destroy previous group is set to true. Okay. And in the bottom will only run when the destroy is false. So that way I can alter the pipeline's flow depending on. Right now it has disable cluster. Checks the so this gives you a sense of how versatile it actually is. We've actually been nope. So we've been actually been using it for a while now, and during our explorations of this new feature, we come up with a few, we call them patterns, but use cases, I don't know, rule of thumbs, whatever you want to call it. So I just want to go over them. So one of them is version pipelines. So one of the things that template pipelines give us is a lot of uniformity, right? You change something in one place and all your pipelines inherit that. So with that is also a big risk. So if you make a small change in one of your templates, that might affect your entire set of pipelines, right? Of your runnable pipelines, and can actually cause a big problem. So what we thought of and what we're doing now is, so you can use a V1 template, right? Have your master template, call it a V1. And when you do want to make a change, since it's all versioned and all in source control, so what you can do is create a V2 of that template, right? And point one of your pipeline, 2, 10, whatever amount of your pipelines you want to that new template. And when you see that's okay, then you can point the rest of your pipeline. So that helps you kind of canary, which is a popular word here, a new pipeline template. Okay, and another thing you can do here is have a shim template, which everyone inherits, and that can be used to use either V1 or V2 for your entire fleet. Okay, so that's something that we kind of experienced, having one of our base templates screwing up everything for everyone. So what we decided to do is that if we want to make, after we've decided on a template, if we want to make changes, it will be to a new copy of it and test it out, roll it out, and then do the change for everyone else. So another thing we found pipeline templates very useful for is actually for creating new services. So let me go back. So before we had Spinnaker or pipeline templates or pipelines at all, what we would do is we'd have a team member, we'd have scripts written for AWS and a script written for GCP that uses that platform's API tools to create the full set of resources that microservices need. Okay, the load balancer, security groups, if it needs Memcache, if it needs Redis, whatever, and just create it all in bulk. But now with pipeline templates, and since, like I said, 95% of our microservices look the same, I don't have to use those scripts at all. I can just copy paste a new configuration for that microservice, create the pipeline templates, create the runnable pipeline, sorry, and then run them, okay? And that creates the full set of services that it needs. So that simplifies the deployment a lot, okay? I don't need to use any more API-specific tools. I can just create the pipeline, the runnable pipeline, and run it with a deploy stage, and everything is already there. Okay, so that simplified our rollout of new microservices a lot. It's also something that developers will be able to do in the future, we hope. So they can write the code, they'll have access to the code and the application and configuration utility, and then they'll be able to create a new runnable pipeline, run it, and their application will be deployed to production. Another one that we found is that we've been able to create, like I said, a pretty good paved road for about 95% of our microservices. But like I said, for that 5% that remains, pipeline templates offers us a lot of flexibility in the terms, like you saw in the movie, injecting stages, adding stages, writing one-off pipelines for specific services which are more complex than our just regular microservice. We have some groups, applications that have dozens of server groups in them. So just using that boilerplate microservice code doesn't always help. Another thing that we've found very handy, you saw before how we have to use ROR to push the templates and push the configuration. So since it's all source controlled and sitting in Git, it was very easy to just have a Jenkins job, pull that configuration repository. Once it sees a change in a pipeline to a pipeline configuration, it will run ROR itself, push that pipeline into Spinnaker, and then run the pipeline itself. So we can have full control or automation the moment you do a change in that pipeline configuration. It's been code reviewed by one of your peers, you commit it, and that change propagates all the way to production, which makes life much more easier, both for us and both for the developers. Yeah, another thing that we do is, or that we needed, that pipeline templates helped us a lot, is sweeping changes. So one of our biggest problems, when you have so many server groups and so many instances running, is making sure they're all up to date in terms of security updates and OS upgrades. So right now we have a big pipeline that runs weekly, and it takes a chunk of the system. It does a bake without changing anything without changing application or configuration, and then just deploying it. Thus, we get a new OS or an upgraded OS for each server group weekly. So this is not related directly to pipeline templates, but what we found with pipeline templates, we could just scrape our repository, and we won't have to manually add. We can create a runnable configuration by scraping a repository and adding new microservices automatically to this. So instead of being toil, instead of being manual labor and having to add every new microservice to this big pipeline, it's done for us automatically, which is not something you consider right away, but helps us a lot. That's it. That's all I have prepared for today. If you have any questions, I'm here. There's Rob here, and I don't know if Daniel's here from Google, which also wrote out the code. So fire away.
Hi. I have 3 questions, you don't mind.
3, okay.
Yeah. Firstly, what version of Orca are you using for this pattern?
So we're still following head or whatever. We're not using the 1.0 version for this feature. It's still not, I don't think it doesn't come out with Orca 1.0, right?
It was pretty alpha in
Pretty alpha in 1.0. So we're still following head just because of this feature.
ROER, is that run on the Spinnaker server? How do you actually execute it?
So it's a binary. It's a binary written in Go, I think. We execute it on a server that has access to Gate. Gate talks with Orca and Front 50 and whatever is needed.
Your pipeline template, you have a source / something that looks like some local file system. Does that
Spinnaker.
have a tendency to the template on the Spinnaker server?
So it means that you have to publish it to your Spinnaker instance before you use it in a configuration. Otherwise, that configuration will fail.
So that means that this ROER has the ability to actually push a file onto the Spinnaker file system.
Yeah, so it does some transforming to the file. I think it turns it into JSON, if I'm not mistaken, and then it just pushes it like an API call to Spinnaker, to Gate.
Yeah, so it's not actually saving a file onto the file system of the server. It's converting it to JSON, publishing it into the API, and then into S3 GCS or something like that.
With all your microservices, I'm curious, do you store those templates along with the services, or do you have a central repository for those templates?
We store them in whatever Front 50 provides, which is, and pipelines are grouped by application. So each application has its own pipelines.
I think the question was in GitHub or Git, in your Git store, are the pipeline templates checked into a central repository?
Yeah.
Or the pipeline templates, they don't live next to the application code?
No, they're completely
Essential.
separate. We have a repository for templates and configuration.
So, sorry, this follows up on this. Even the configuration lives outside the application in your case?
Yeah. Because it has no sense. The application itself, the code itself is something that's developed by our developers. For us, we're the infrastructure team, they're the development, so there's no sense for us to store it with the application. Much rather have it somewhere central where we can manage it, where we can have a Git Jenkins job, monitor it, and update the pipelines accordingly.
What about cross application common configuration?
What term? You mean?
What about your patient configuration that's common across applications? Like in Jenkins, you have the concept of shared library. You can share application-specific configuration in the application repo.
Right. So in templated pipelines, the shared code is a template, right? If you remember this slide, this is a shared code, right? That can be mutated how many ever times you want by configuration.
You called it shim. You had one slide where you talked about shim.
Yeah, that's for versioning. So you can have all your templates inherit one template. That template, you can then use to switch between versions of your whole pipelines, your golden template or whatever you want to call it.
But you use a term that shims could be used in across different.
Well, you can always have an empty template, right? But there's not much use for it.
Can you talk a little bit more about how you'd be rolling out updates of the base pipeline? So you kind of talked a little bit about creating like a V2 version of it. So when you've tested that V2 on just like a dummy pipeline, how would you then update your entire fleet? Would you just flip V1 to basically have V2, or would you roll it out slowly? How exactly would you kind of handle that model?
I will roll it out slowly.
Mhm.
That's exactly what I was talking about a shim.
Oh, okay.
So I can have all my configurations source one single template, and that template can source or inherit all my golden template, right? And then I can use that shim to just switch my golden templates.
Cool. And you would just do that manually by updating each of the.
Yeah, so I test a few. And then that's the power. I don't have to just change it in one place, and I push that pipeline that template. And all my pipelines are now using that new base template.
So I'm getting the feeling that the application developers aren't running the pipelines, are they? They're being run by.
So they do.
Okay, they do.
They wouldn't
they're
do
not-
all the ad hoc work where that we did, but now that we have this and we have integration back into our application system, our upgrade system, so I can have a pipeline that will be set latest version, bake, right? And then run some sort of canary or the homegrown canary, deploy another canary, whatever. right? But once we have that, we can confidently tell the developer, okay, you have a pipeline. You can run it by yourself. You don't have to ask for our permission. You don't have to talk to us. Here are your dashboards. Go upgrade by yourself.
But they're not managing the pipeline. They're not changing
Not
anything.
yet. This is all kind of new for us as well, right? We're not comfortable yet asking a developer, okay, so here is a sample configuration, go create a configuration for your application, because it has stuff like regions and security groups and load balancers, which is stuff that developers usually are not aware of.
So are they able to, like, when you have that runnable pipeline at the end, are they actually able to go change anything in there, or since it's from a managed pipeline template, is that really locked
So
down?
our developers don't want to change anything. They're just happy.
Our
with
developers.
most, okay? I'm not gonna, so they're happy just to go in, click run,
Okay.
and wait for the email telling them that everything finished. No, once you have a template, a pipeline that's built out of a template, you can change the template itself. You can configure it like you saw with flags,
Okay.
which will affect maybe its flow, maybe other parameters like security groups, regions, whatever, but you can't actually edit it.
Okay.
To follow up on that, so you can change variables. So whenever you need to, you can configure variables on your config.
Right.
Do you have use cases for where pipelines need to be parameterized? So you want to execute that pipeline with different parameters? Or are you mostly using just variables?
So we do have those, but that's in the configuration, right? That's in the pipeline configuration.
So you don't have them in the
So
template.
that's like another layer on top of, on a runnable pipeline, you have configuration which can affect the flow. So we can have conditional stages, stuff like that. But that's separate from having a conditional stage on the pipeline template level, which is a template variable. Those are very confusing terms. So this is the pipeline configuration, which can tell you, like, for this pipeline, don't set the latest version, or for this pipeline run, don't set the latest version, or don't bake, or don't deploy, or whatever. And that's for a regular pipeline. That's what you see in the first part of an pipeline. That stays. That doesn't change.
So you don't have use cases where your template defines a bunch of parameters that we'll be using when we.
Yeah, all our templates are like that. So each pipeline, they're all the same, but then there's the small things that define maybe the application, right? The OS, some have to run on 1604, Ubuntu 1604, some still have to run on 1404 because they have some agent dependencies or whatever. So there are stuff like that. Or maybe we don't want canaries for that. There's all kinds of stuff that you can put in the configuration that will affect the runnable pipeline, but that's not part of the template. That's part of the pipeline.
Is there current tooling to basically produce runnable pipelines locally without like a Spinnaker running?
Not sure. We wrote a script that will take a server group, look at it, and change it into a pipeline configuration. That's for us. So we can base it on template and then just do like a roll and sweep, go over all application, all the server groups. And when we're ready, push it all out. But I'm not familiar with anything that just, maybe there'll be something in the UI. I don't know. Later on, there'll be some kind of, a template editor or something like that. But right now, Emacs or Vim, choose your weapon.
So you showed a sample template, which was a minimal template.
Yeah.
For more complicated templates, I mean, do you just have to write out the YAML, or
Yeah.
is there something that helps build that up?
So that's
Like,
what I
can
was
you
saying. There's
build
no,
one in the
there's,
UI and export.
there's no editor or some UI which you can use to generate. There's
Third bullet.
third bullet, right?
Okay,
There's
there is
more,
a
and there's-
converter.
You can read the spec, right? And
Yep.
like I said, it all kind of maps one-to-one to whatever you see in the UI. So it's pretty intuitive, I think. Once you start writing it and you have your first template, you'll see that usually it fits most of your use cases. And I know
Okay.
going from there will be probably pretty easy.
All right.
Yeah.
In the YAML configuration, is there a one-to-one correspondence to every feature that you can do in the UI? Or is there like 90% coverage and some things that you can do from the UI, but you can't currently do in the template? And follow on to that, what happens when Spinnaker in the UI releases new functionality? Do we have to then wait for an update to this to be able to migrate that over? Or is there some kind of scheme where it just knows how to convert from JSON, from the YAML to the JSON?
Based on Rob's head nods, you have 100% coverage, right? I mean, in the UI, because right now a pipeline, if you look at it, a pipeline is, you can always edit the JSON. So what it does is create a JSON, right, that you can change. And in terms of new features, so I'm guessing it's the same, right? Once a feature is there in the UI, you can add it to your template.
Okay, so it's just mapping. Awesome.
Yeah.
So you mentioned that in addition to publishing things to Spinnaker with Rower, you could use like an HTTP endpoint for the templates. Does Spinnaker poll that to see if a change has happened, or when does the pipeline actually get generated and created? Is that when the pipeline is executed, or is that, you know, if you don't publish it to Spinnaker but you update the file? How does that
So let Rob answer.
Templates are resolved right at execution time.
Yeah.
So if you have HTTP before the pipeline actually starts, it'll grab that template and then generate it right before it actually executes.
Is there any caching? So in the event my HTTP went down?
No. It's HTTP is kind of there for getting started very quickly. It's not really meant to be like.
You probably wouldn't use it that way, but I was just curious since I knew it was a thing that existed.
So it makes sense, right? So every time you want to change a template, you want it immediately reflected in your runnable pipeline. So.
Yeah, I just want to comment the converter. We're using the converter for all our work, and you can just define a pipeline in the UI. If you want HBA or something on Kubernetes, you just define a pipeline which has HBA, and you use the converter, and you get the YAML for free.
Right.
So to get started, the converter is super awesome.
Right. I think it's in the one of the. Which repository is it's in Spinnaker?
So there's like two different ones.
So there is actually, thank you. There is a converter that will take a pipeline, right, and generate a template out of it.
Yeah. So there's the original converter, which is Python, and it's just a personal repository on my account. And then there's a converter that's built into Rower that does basically the same thing. But I kind of like the Python one more.
Right, so that can help you get started out. So if you build your pipeline in the UI, then you can dump it into a YAML and start changing it from there.
Spinnaker or Roar actually validate the template?
Yes. Roar doesn't actually do any validation. It's all done through Orca. But if you do like a pipeline template plan through Roar, it will basically do a dry run of the template with your variable bindings. And then if there's any issues, it will print out the errors.
Do that many a times. Yeah.
I think one thing that my team thought of in looking at the new templates was basically we were concerned about the prospect of having logic in YAML, and we ended up sticking with our homegrown for now. Have you run into any of the limitations of expressing your ideas through the control structures available to you in the template system?
So we have run into a few, but these are really features that we are missing, not really limitations. I mean, it's stuff that Rob said he'll write for us. So we're kind of okay. But in terms of ideas, no, we've been able to, because it's, it's a representation. We have models which help you write code reuse, and there's partials which help you reuse a whole bunch of stages. So we haven't run into those kinds of problems yet.
If you wind up having some feature gaps for pipeline templates, you just ping me on Slack, and we'll go through some design docs. I've done that multiple times with Waze and internal teams at Netflix. and we'll try to make something work.
So assume that, for example, you want to version lock pretty much everything. In other words, latest tags and so forth don't fly. Everything is very repeatable throughout the process. And I'd also have, for example, version locked pipelines and so forth, version lock configurations. I'm just trying to understand, because I see you're kind of sitting on the fence between being able to handle both, because culturally, but we do both. How does this make sense in your world to actually version lock kind of everything? So I know essentially have either a manifest of versions that went into each thing that's deployed, or even a version number saying this is my release.
Yeah, because we like to know what we push to production. I mean, we kind of maybe we're over the top with that kind of stuff, but we want to know what we push to production. We want to be sure that's been tested out properly. So I'd much rather have everything locked to one version and then migrate to a new one than have a mishmash of versions and stuff that I don't know and then I can control. Does that answer your question?
Yeah, so in other words, I mean, that's really your intent, as opposed to, because when you talk about, hey, I changed something and now it's magically get applied to lots of things, that magic implies that either their versions don't change because they automatically suck up, and it happens with recipes and all the rest of them, unless you go through the extra effort of saying, no, I only take this version of that recipe unless I actually upgrade. I mean,
Yeah. So I'll be honest, we haven't reached version 1 for us yet. So, but I guess when we do, again, speaking for our use case, we have a lot of similar stuff. So we will lock that thing up. There's a new feature, there's something we want to test out, we will do it in a V1.1 and then roll it out. Yeah.
Why do you define your pipelines in YAML and then translate them to JSON rather than just using JSON as Spinnaker already does to describe the pipeline?
So we don't have to convert them. Roar does that for us. Why YAML? There's a whole paragraph on that on the spec page. Rob can maybe say comment on why YAML, not JSON.
Basically, chose YAML because it's less code to write. So if you're actually writing the template manually, you don't have to deal with like curly braces and that sort of thing. It's more of just like a end user convenience thing. If you want to write your templates in JSON, it's fine. There's nothing preventing you from doing that.
Okay, just think, let's say you want to just copy and paste your current pipeline from Spinnaker. You can just like, copy the JSON and then paste it into a file and use that. Whereas if you look to use this system, you would have to convert the JSON to YAML, then go the other way as well.
JSON is valid YAML, so.
Yeah, so you could just copy the JSON if you want, or if you don't want to do that, there's the convert functionality, and eventually that's going to be something inside the UI. So you just like go into pipeline configure and then like convert the template, and you would do all that within the UI, and then you just copy it out.
Okay. I think it's time for lunch. Thank you very much.